You know, now that you're famous, don't forget about your family. So we're going to go visit your mama and we're going to give her some flowers here. And we're going to utilize that Shell's method that you got so good at. And we're going to find the volume of the region bounded by the equations f of x equals x and g of x equals x squared when rotated about the y-axis. So once again, both these are continuous functions, and what we want to do is utilize that theorem that we had in the last video. So notice, if we rotate these flower petals around, this flower petal around out and about the y-axis here, we're actually going to get a V-shaped empty bowl in the middle, and then on the outside is going to be kind of a rounded green bowl and whatnot too. So the volume is going to be given by the area in between rotated around. So let's just look at just a particular x value here. If I have a particular x value, if I'm over x, I'd be left x, kind of mirror image here. I'm going to show you what the cylinder looks like here as we go around. So once again, if we take that cylinder and we drop it down in there and we want to add up all those cylinders as we go out, we're going to go from 0 to 1. But the volume, if we use the Shell's method in this case, is going to be 2 pi times the definite integral from 0 to 1 of x times the top one minus the bottom one. So in this case, this height here is going to be x minus x squared, and then with respect to x. So we can just calculate it this way. Remember, we're adding up the areas of all those cylinders, and the cylinder would be the base, which is the circumference of the circle, 2 pi r, in this case 2 pi x, times the height, which in this case is the upper height minus the lower height. So let's go ahead and calculate this out. This would actually equal 2 pi times the definite integral 0 to 1 of x squared minus x cubed with respect to x. We can go ahead and take the antiderivative here, and that's going to be 2 pi times x cubed over 3 minus x to the 4th over 4, evaluated from 0 to 1. And then I'll go ahead and do that. So this is going to actually equal 2 pi times, if I plug in 1 for the upper limit, it's going to be 1/3 minus 1/4. And then minus this evaluated at the lower limit, which would be minus 0, right? So basically it just becomes this. I get a common denominator here. 1/3 is basically 4/12 minus 3/12 would be 1/12 times 2 pi is actually pi over 6 cubic units. So not only did we bring the roses home to mama and celebrate our championship with the family, but then mama gives you a big hug, because not only is she happy to get the roses, she's ecstatic that you're doing well in calculus.